Good afternoon, students. Welcome to another in our series of workshops that we've been having over the last 6 weeks. We're at our final leg, and today we will be delving into the problem solving. It is most commonly called the investigation question. Now, today, students, at the end of the session, we would like for you to be able to explore patterns, generate rules from patterns, generate rules from sequences, and then use rules to find the nth term expression. However, before we begin, I would like for you to make sure that you have these items. Make sure that you have your ruler, your pens and pencils, your calculator, as well as your notepad. These are very important. Now, in this type of scenario, this type of question that we're going to be examining today, you're going to have to be playing detective. So to get you in that frame of mind, I would like for you to think on this activity here. So I'm giving you a few seconds to read it for yourself. All right. All right, we're ready. Shannon's house was robbed one Sunday morning. While she was checking for mail at the post office, while there, she remembered that the opening hours are 8 a.m. to 3 p.m., Mondays to Saturdays. The police knows who they are going to arrest from a bit of information, and the information that the police have after checking various persons' alibi is this. Now, Alyssa was doing laundry. Reggie was cooking. April was at the post office getting the mail, while Mark was planting in the garden. Who robbed Shannon's house, and how did the police know who to arrest? Now, my friend Mr. Hilton will be checking the chat for those detective among you who can give us that response.
Okay, Mr. Montague. I'm seeing the chat being lit with April. So I'm seeing a lot of persons saying April.
Wonderful, wonderful. All right, could you select someone from the chat who would then tell us why did they select April?
Okay. Nastasha.
All right, Nastasha, please go ahead. Or you may unmute Nastasia.
Oh, I wasn't sure if it was me. Sorry. It's April because the post office is closed on Sundays.
All right. Wonderful, wonderful, wonderful. Yes, it was April. All right, so I see that you persons are ready. No, let's look at this sequence. And I want for you to tell me what will come next. Examine it carefully. All right.
And we also have persons on YouTube saying April also. So we have King Orthodox saying April.
All right. Great going, King Orthodox. Great going. All right, is there any response coming in the chat for what comes next in this sequence?
Okay, so I'm seeing person saying 1.
1. All right, that's great. All right, I'm going to ask that you select one more person who's just going to explain how did they see that the next in the sequence would be 1.
Okay, Damani Thomas.
All right, Damani, you're up. Please unmute and share your observation, Mr. Detective. Damani, are you ready? All right, has Damani been unmuted?
It seems as if he is not able to unmute at the moment. So let's go for Romain.
Romain, could you share, please? Are we seeing a pattern coming out, students?
Yes, sir.
All right, wonderful. What's the pattern that you're seeing?
A matchstick is being removed in every number.
All right. And so if one is being removed each time, then the last one or the next in that sequence would have to be 1. So I am agreeing with your observation. Wonderful. And this type of observation is very crucial when we go into the investigation type questions. All right, colleagues and students, I want for you now to open up the chat and we are going to be just sharing your understanding. So at this time, I would like to know how you would define a pattern. All right, so you're going to just quickly raise your hand and Mr. Hilton will select someone who would share their definition of a pattern. Yes.
Not seeing anything yet, Mr. Montague.
All right.
So we're seeing a Simpson raising hand.
All right, could you go ahead, Ms. Simpson?
So a pattern is like a pattern follows a particular sequence. That's what I have.
All right, wonderful. All right, Zanik Reed, similar thing. I'm going to keep you right there and I want for you to tell me how you would define a sequence. Is there anything that's up in the chat, Mr. Hilton?
Not yet, Mr. Montague. And I'm monitoring Facebook also because we have a few persons on YouTube. That's YouTube.
All right, welcome to our viewers on YouTube. All right, so we had Ms. Simpson defining a pattern and we would like someone else to define a sequence. All right, Zanik, you ready? Go right ahead.
Yes, sir. Sir, I would say a sequence is a set of related objects or items.
All right, wonderful, wonderful, wonderful. So would you then say, is there a difference between a pattern and a sequence? Anyone else?
All right, so in the chat, we have Malachi saying a sequence is the order in which something is arranged or appears.
All right.
We also have Catherine saying sequence and arrangement of things in ascending order.
All right. All right. Now, students, if we were to have a die and we were then to throw it 20 times, and each time that we throw it, we then write down the number that is on the upside of it. That or those values would create a sequence. But if they are not in any discernible order that we can say there exists a rule that we're following, then it is not a pattern. So I have a definition here. And it states patterns refers to procedures or rules that can be followed. They predict what comes before or after a set of figures or numbers when arranged in a specific order. The arrangement of numbers is called a sequence. All right. So this is just one definition. There are myriads of definitions out there that we can use. All right. So we have an example here: 4, 8, 12, 16, and 20. Now, these are numbers that form a pattern. It's a sequence. Now, there's something I want for you to remember. The numbers that we're looking at, each of these are called a term in the sequence. So the first term is 4, the third term, 12, the second term, 8, the fifth term would be 20 in this instance. Also, students, these definitions are very important because you're going to be seeing them in your questions. The nth term. Now, this is an expression that enables you to find the term in the nth position of a sequence. So if you want the third term, you then replace n with 3. If you want the second term, you'd replace n with 2. If you want the first term, you'd replace n with 1 in this instance. Now, coefficient, you have been used to coefficient from as far back as grade 4. Now, it is that constant that is used to multiply a variable in an algebraic expression. So in this example also, we have 2n, while the coefficient here is 2. Great. Now, students, we are going to be using that detective brain of yours as we are about to explore some patterns. Now, I want for you to look at the figure that I'm going to display, and I want for you to determine the pattern that would be derived in figure 4, and I want for you to give me the number of dots. So look at it. You have 75 seconds. All right, Mr. Hilton will be monitoring the chat because I know there are a number of persons who will be fast out of the block. Remember the question? How many dots will be in figure 4?
Okay, so I'm seeing some responses in the chat, Mr. Montague. So we have Brooke saying figure 4 has 14. I'm seeing Vanessa saying 14. I'm seeing Reed saying 13. I'm seeing Sarah saying 14. Angel 14. White 14.
All right, great going, students. Great going. All right, now I want for you to note how some other students saw these patterns. All right, and we are going to be looking at how they got their figure 4. So Paul, when Paul looked at the 3 design, he saw 5, then he saw 5 and 3 added, then he saw 5 and 6 added. So if we're following this instance or this example, would he get the number of dots that would be in figure 4? What would he say? 5, and how much would be added in this example? All right, wonderful. All right, let's look at another student here. So when Karen saw the design, what Karen saw was 2 and 3 added, then 2 and 6 added, then 2 and 9 added. So following her design, once she has decomposed it, would she be able to get the 4th figure or the correct number in the 4th figure? Very good. Very good. Coming from the chat. Very good. All right. Another student, Adam, when he decomposed the 3 design, he saw 3 and 2 added, then 4 and 4 added, then 5 and 6 added. So it's important for our students when we're looking at a question in the investigation section that once we decompose the design, we see if we can identify patterns that are coming out. So we're able to identify the next term. So following this example, all right, this is what we recognize. Figure 1 had 5 dots, figure 2, 8 dots, figure 3, 11 dots. And so figure 4 would have how many dots? Are we getting that overwhelming number in the chat, Mr. Hilton?
Yes, Mr. Montague.
All right, great going, students. We are there.
And also YouTube is on the ball also.
YouTube, congrats. All right, so yes, we will definitely have 14 in the 4th figure. But now, students, another 75-second question. How many dots are in the 40th figure? And your time begins now. All right, wonderful. Our time is officially up. Yes, our time is up. All right.
Mr. Montague, I am seeing responses in the chat. So I'm seeing Che Tamala saying 122, and I'm seeing Wilson saying 122.
All right. Great going, great going. All right. We won't be taking your reasoning just yet, but we'll be going through and taking the other students with us. All right. So what the aim of that question, we want for you to recognize, students, that decomposing the design will allow you to predict and design the next term and possible for other term. However, we're working in a time-sensitive exam. So it would be much easier for us to identify the formula that is governing the sequence. And once we're able to do that, then it would be much quicker instead of having to draw each pattern. All right, I'm even seeing some response coming in the chat, fast and furious. Congrats. Now, students, I want to bring to you how it is that we'll go about generating the nth term expression. So we looked at the number of dots associated with each figure. And we recognize that figure 1 had 5 dots, figure 2, 8, figure 3, 11, figure 4 at 14. Now, I want for you to recognize if there is a difference in the number of dots between figure 1 and figure 2. If there exists a difference, what is that difference? All right, so we're seeing that difference coming on. Great. I love the participation that we're getting here.
Yes, so I'm seeing person saying 3.
Great. All right, so there's a difference of 3 between figure 1 and 2. There's a difference of 3 between figure 2 and 3. There's a difference of 3 between figures 3 and 4. Now, this is called the common difference. In some books, you'll see it being referred to as the term-to-term rule. All right, so in this instance, you can either call it the common difference or the term-to-term rule. Now, we're going to be using that, so please hold on to it. We're going to be exploring our patterns a little bit more. So we recognize that the first figure increased by 3 to get the next, which is what we just saw, the common difference. So that would mean that the first term being 5, it would be 3 plus 2, which would be one group of 3 plus 2. The second term, which is 8, would be 3 plus 3 plus 2, or 2 groups of 3 plus 2. What would be our third term? All right. I'm hoping that you're seeing this pattern. All right, anyone want to share in the chat what they notice? What the third term would be? Look at the pattern that we're seeing here. Mr. Hilton, are we seeing what we want?
I am seeing Jarrett, Brooke, White saying 3 times 3 plus 2.
All right, so we're seeing what we want. Wonderful, wonderful. All right, so the third term would be, yes, it would be 3 times 3 plus 2. Likewise, the fourth term, it would be 4 times 3 plus 2. So once we're able to recognize our pattern coming out, then we would then be able to say, oh, to find the nth term, I would be adding 3 a certain number of times and then 2, or I would be multiplying 3 a certain number of times and then adding 2. So we could further simplify and say the nth term would be 3n plus 2. All right, wonderful. All right, let me take you to something else. We're still working with the pattern that we just did. Some of you might have looked for a pattern and tried to use it to predict the 40th term. But did you relate the number of dots, D, to the figure number? And that is how CSEC would be asking you to interpret the nth expression. They always ask you to relate some letter to another. So we need to be aware of that. So if we were to do that, then we would have obtained D is equal to 3n plus 2. All right, great going, students. I'm enjoying the participation. All right, so we're still focusing on the common difference here. All right, and we're going to be using it because this is our sequence that we have been working with so far. All right, so we have recognized that the term-to-term rule is adding 3. So we have added 3 to 5 to get 8, added 3 to 8 to get 11, and we've added 3 to 8 to get to 11 to get 14. All right, so in this instance, you would say that the coefficient of n is 3. So we would then write 3n. So the common difference, the term-to-term rule, they give us the coefficient. All right, so if we're saying that the coefficient is 3n, or the coefficient of n is 3, so we would be working with 3n. So if we were to substitute to find the first 4 term using 3n, we would end up with 3, 6, 9, and 12. But that's not what we have. We actually have 5, 8, 11, 14. So once we have gotten our coefficient and we have substituted, we now need to ask ourselves, what other operation can I do? Can I add something? Can I subtract something in order to get the first term, and will it work? So what do I need to do? What other operation do I need to do to, let's say, 3 in order to get 5? Are we able to see that coming out, students? All right. So most persons.
I'm seeing persons saying add.
All right, so we need to add specifically how much? Are we seeing what we want?
Add 2.
Great.
Simpson saying add 2.
All right, so we're seeing what we want. Great going, students. Very good. All right, so that would be how we end up with this rule, 3n plus 2. So those of you who weren't following before, I hope you're with us at this point. All right, so I want to see if this rule works. So we're going to continue working a little bit more. All right, so in this instance, students, I'm going to bring up some sequence and I want for you to tell me what is the term-to-term rule. We're not going to just be calculating the nth term or deriving the nth term expression just yet. I just want for you to tell me the term-to-term rule. What do I need to do? All right, so we're ready. And I want for you to blaze up the chat. What is our term-to-term rule? What are we doing here?
So I am seeing persons on YouTube saying 2. So King Orthodox is saying 2. So I believe he is responding to our previous question.
All right, going fast. All right. I want for you to tell me, am I subtracting? Am I adding? How much am I doing this by? All right. So quickly, are we seeing the response that we want?
Yes, persons are saying add 4.
All right, great going, students. You know what we're doing. Do the same with this one. What are we doing here? Continue blazing up the chat as I bring them up.
So persons are saying +5, +5, add 5.
Great going. Come on, continue. Don't stop now. Are we seeing what we want, Mr. Hilton?
Yes, sir. I'm seeing persons saying -3.
All right,
Subtract.
great going, students, great going. Don't stop just yet, continue. Are we seeing what we want?
So I'm seeing -2, -2.
All right, great
Minus-
going, great going. Continue, students. What are we doing here?
So add 2, plus 2, add 2.
Are you sure? If we add 2 each time, will it work? Come on, look closely.
And I'm
You're
seeing
my detectives.
person saying multiply by 2.
All
Times
right.
2, multiply 2.
Great going, my detectives. Great going, great going. All right, now we're going to be examining this nth term, and we want to see the sequence that it generates. All right, so I want for you now, students, listen up, listen up. So we have n plus 2, and we want to see the sequence that it generates. So I want for you to give me the first 4 term in the chat that we will generate using n plus 2. First 4 term. First 4, so I want the first, second, third, fourth.
So I am seeing 2, 4, 6, 8. I'm seeing 3, 4, 5, 6. And 2, 4, 6, 8 again.
All right, students, I want for you to know, each time when you're seeing this, it's a bit of substituting at work. So for the first term, it would be 1. So n would be 1, so it would be 1 plus 2. The second term would be 2, so it would be 2 plus 2. The third term would be 3, so it would be 3 plus 2. All right? So we'd be looking at something like this. Bearing that in mind now, students, I want, what would be the term-to-term rule for this?
So I'm seeing +1.
All right, wonderful, students. Great observation, my detectives. All right, so I want for you now to look at this nth term, 2n plus 5, and the sequence that it generates. And I want for you to put in the chat the first 4 term that we would get. First 4 term. Great going, my detectives. First 4 term, are we seeing what we want? First 4 term.
So I'm seeing so far 7, 9, 11, and 13.
All right. Great going, my detectives. Great going. All right, so what would be the term-to-term rule that we would be seeing from this one?
So I'm seeing +2, add 2.
All right, great. So we're all traveling along quite comfortably. All right, so our term-to-term rule would be, yes, +2. Now, since we have been given all of this, let's look at it together. All right, so with our nth term n plus 2, it generated the sequence 3, 4, 5, 6, 7. Our term-to-term rule was +1. When we add 2n plus 5, the sequence that it generates, 9, 7, 9, 11, 13, 15, our term-to-term rule would be +2. All right. So as we're looking at that, I want for you to notice the coefficient in each expression and the term-to-term rule. Look closely at those. The term-to-term rule, the coefficient. Do you notice anything, students? All right.
So I'm seeing Reed saying yes.
All right. Lovely, lovely, lovely. I want persons to recognize that they are the same. The term-to-term rule actually ends up giving us the coefficient. All right. So we need to bear that in mind. So once we're able to identify that, remember we started the common difference. Remember that. The term-to-term rule, the common difference is what will end up viewing our coefficient. All right. So now in the instance, the first instance, for those who are not seeing it, the coefficient of n is 1 because if we multiply n by 1, we know it's still going to be n. All right. Now, students, we're going to try this example here. I want for you to tell me what would be the term-to-term rule. Put it in the chat, and let's see if we can do it together. Are we seeing what we want, Mr. Hilton?
So so +4 is being typed in the chat. +4, adding 4. So I'm seeing a lot of +4s.
Great going, students.
And
No.
YouTube is also with us and doing great.
Great going, YouTube. All right, now I want for you to tell me what would be the coefficient of n. Put that in the chat. Blaze the chat. Coefficient. So we know what our coefficient is.
All right, so persons are saying 4.
All right, great going. So we would start off term-to-term rule being +4, and we will start off with 4n. Now, if we were to use 4n, what sequence would 4n generate? Type that in the chat. First 4 term, if we were using 4n, what would it generate? What sequence would it generate? Come on.
So I'm seeing 4, 8, 12, 16.
Great going, great going. So now we need to ask ourselves, what other operation can we implement in order to get the sequence that we want, the terms that we want? Come on, students, my detective, you know what to do. What should we do?
So I'm seeing -1, -1 so far.
Great going, my students. My detectives, you're on the ball. So we'd end up with our nth term expression being 4n minus 1. Great going. All right, students. So to summarize finding the nth term, all right, we need to find the term-to-term rule, which we know referred to as the common difference. All right, then we need to find out how much we need to add or subtract to get that correct sequence. And then we check to see if our nth term work for the second, third, and subsequent terms. So you might want to take a picture of this if you want. But I know that you have committed all of this to memory already. All right. So at this point, I will hand over to Mr. Hilton, who will continue.
Okay, thank you, Mr. Montague. All right, so let's consider the sequence. So here we have an arrangement of matchsticks, right? So we're asked to determine the number of matchsticks that would appear in the 5th figure. So let's look at this pattern here. What can we say is happening between these 4 patterns? What's consistent? What are we seeing consistent? What's being done to the first pattern in order to get the next? What is being done to the second pattern in order to get the third? What's being done to the third in order to get the fourth? So what's happening in the chat, Mr. Montague?
Yes, Mr. Hilton, I'm seeing persons saying 4 is being added, add 4, 4 sticks are being added. All right, so the fifth term would be 21, and that's coming from Camila White.
Okay, great. All right, let's see what's next. So these are our 4 patterns, right? And we're asked to determine the number of matchsticks in the 5th pattern. So I want for you to sketch that 5th pattern for me. How would that 5th pattern look if we're adding 4 matchsticks each time? So you can sketch it, get your notepads, make a sketch, and send in the chat for us.
I'm seeing in the chat, Mr. Hilton, 21 is what is coming up. So
okay. Okay. All right, great going, students. So let's see how our 5th pattern would look. So our 5th pattern would look like this, right? So since we're adding 4 matchsticks each time, we'd add 4 matchsticks to the 5th pattern in order to get the 5th. So we should have our 5th pattern looking like this. All right, let's see what we have. So by counting the number of matchsticks in each pattern, we know that the first pattern has 5 matchsticks, right? And we're saying that we add 4 matchsticks to that in order to get the second pattern. So following that, we'll have 5, 9, 13, 17, and 21. So our 5th pattern would have 21 matchsticks. And we know that that 4 would be our term-to-term rule or our common difference. So from this information, can we generate the rule for the nth term? What would the rule for the nth term be? Knowing that the common difference here is 4.
all right, Mr. Hilton, I'm seeing it's being blazed in the chat. Brianna Rodney, Camila White, Shaquem Morris, Miss Burke, Miss Reed, they're all putting in 4n plus 1. Chevelle Watson, they're right on the ball. We're seeing what we want.
Okay, awesome. All right, so let's see what we have. We know that our common difference is 4. So that 4 would become the coefficient of n, right? So if we're supposed to generate the sequence for 4n, what would we have? What would the sequence for 4n be? This is the first 5 terms. All right, so what would the sequence for 4n be? Any responses yet, Mr. Montague?
Yes, Mr. Hilton. Franklin is saying, can you explain it a little bit, please? To me a little, please. From Vanessa, I'm seeing 4, 8, 12, 16, 20. Velisha, Zanik, they're giving the first 4. 4, 8, 12, 16, 20, the first 5.
Okay, thank you. All right, so what we're doing, we're looking at the figures given, right? So we're given 4 figures, and we're asked to generate the 5th figure following the same pattern, right? So we notice that from the first figure to the second, we add 3 matchsticks. And from the second to the third, we also added 3 matchsticks, right? We move from the third to the fourth by adding 3 matchsticks, right? And if we're following that pattern, that simply means in order to get our 5th pattern, we would add the same amount of matchsticks to the fourth.
So we're adding 4 each time?
4 each time.
All right, great going.
So our series, if we have our common difference, right? In this case, our common difference is 4. And our common difference is the coefficient for n. So we'd have 4n right there. So if we're looking at the series for 4n, we would have 4, 8, 12, 16, 20. That would be our first 5 terms. But that's not what we want. We want 5, 9, 13, 17. So what quantity can we sum to a series of 4n in order to get the required series, which is 5, 9, 13, 17. So I'm seeing person saying +1. Okay, great. So if we add 1 to that series for 4n, right? So our first term in the 4n series would be 4. So 4 plus 1, that's 5. Okay, great. Our second term in our 4n series would be 8. 8 plus 1, 9. Our third term in the 4n series would be 12. 12 plus 1, 13. All right, that seems to be consistent. So the rule for our n term now would be 4n plus 1.
I believe that should have cleared up any misconception that our young friend was having.
All right, so let's see what's next. So we're given this table. So we're looking at some figures, right? And we're asked to write the difference here, which is the common difference, and find the 5th term and the rule for the nth term. So use 2 minutes and complete this table for us. So what's the difference? What's the number of matchsticks that would be in the 5th term? And what's the rule for generating the number of matchsticks in the nth term?
All right, Mr. Hilton, I'm seeing in the chat, some persons are saying 3. 3, I'm seeing 3 coming. The next term would be 16. I'm seeing that coming out in the chat.
Okay, great, great. All right, so the number of matchsticks in our first term is 4. The number of matchsticks in our second term is 7. The difference of 7 and 4 is 3, right? And that's consistent among the terms. So that would be our common difference right there. So using our common difference of 3, if we add 3 to the 4th term, we would get our 5th term. So we're working with 13 for the number of matchsticks for our 4th term, right? Adding 3 to that, we'll get 16. So our 5th term would have 16 matchsticks. So what would be the rule to calculate the number of matchsticks in the nth term?
All right, Mr. Hilton, I'm seeing persons having Camila White, I'm seeing 3n. I'm seeing from Asha Nepal 3n plus 1. I'm seeing also from Camila White 3n plus 1.
Okay, amazing. All right, so we know that our difference here, our common difference, or term to term rule is 3, right? And we know that for our expression, we're gonna have the 3 being the coefficient of n. So we have 3n right there. So looking at this series for 3n, what would the series of 3n be? So can you type the first 5 terms of this series for 3n?
I'm seeing the response that we're looking for coming in the chat. 3, 6, 9, 12, 15. They're coming fast and furious in the chat.
Okay, okay, great. So our first 5 terms of this sequence would be 3, 6, 9, 12, 15. But what do we want? We want 4, 7, 10, 13, and 16. So what quantity can I sum to that sequence of 3n in order to get 4, 7, 8, 13, 16?
The response we're seeing coming that we want, we're seeing +1. Some persons are then putting in their final Nth term 3n plus 1.
Okay, okay, great. So if we have 3n plus 1, let's see if that would generate our third term. So 3n plus 1, we're our third term. So we're going to replace n in this case with 3. So 3 times 3, that's 9 plus 1, that's 10. All right, that seems to work for our third term. Let's look at our fifth term. So 3n plus 1, where n is 5. So that's 3 times 5, 15, plus 1, 16. All right, so we're on the ball so far. So our expression to get the number of matchsticks for our n term is 3n plus 1. All right, so we have another question right here. So use another 2 minutes to generate the difference, the fifth term, the term that has 122 matchsticks, and the expression for the nth term.
I'm seeing persons coming, we're going up by 4. We're adding 4 plus 4. And some persons have jumped the gun and gone to generate the Nth term already. Great going.
Okay, okay, so we have some smart persons here. Wonderful students. All right, so we can safely say here that the difference is 4, because to move from 6 to 10, we would add 4. From 10 to 14, we would add 4. From 14 to 18, we would add another 4. So our difference here, our term-to-term rule is 4. So what would our fifth term be?
The chat is flooded. We're seeing 22. We're seeing what we want, Mr. Hilton.
Okay, okay, so let's see. So our fourth term is 18, right? And to move from our fourth term to our fifth term, we would add the difference, which is 4. So 18 plus 4, that's 22. All right, great. So if we're given a term and it says that the term has 122 matchsticks, what term would that be? What term has 122 matchsticks?
I'm seeing the chat being flooded. We have persons jumping the gun again, but the response is there that we're looking for. We're seeing 30. Great going. Daniel, thumbs up. Zanik, great going.
Okay, so how would we get that 30? So one thing that we could do here, we could add the difference until we get that 122, but do we have enough time to do that? Remember, CSEC is a time-sensitive exam, and we have to be mindful of the time. So what we do here would generate the expression for the nth term, right? And what would that expression be? The expression to calculate the number of matchsticks for the nth term. Remember, our difference will become our coefficient, right? and then we add a quantity to that in order to make the sequence that we need.
Yes, sir. We add or subtract as needed.
Yes, we sum a quantity to it. All right, so what are we seeing for the expression to calculate our nth term?
I'm seeing responses just coming in for n.
For n?
Right, I'm not seeing what we're looking for just yet.
Remember, students, in order to get the expression for our nth term, we know that our difference will become our coefficient of n.
It's coming in fast and furious now. It's coming in 4n plus 2. We're seeing what we want.
Okay, great, great. So now we have our expression for our nth term, right? So how would we use that expression given that we know the nth term in order to find n? So from our algebraic skills, right, we can apply the principle of equality, right? So if we know the nth term and we know the formula or the expression to calculate the nth term, what we would do would equate the nth term to the expression to calculate the nth term and solve for n. So doing that and simplifying, we'll get n to be 30. So in this case, our 30th pattern would have 122 matchsticks.
All right.
All right, let's see if we have any more like this.
We're seeing some responses. Zani, great going. You have worked it out in the chat. We're seeing that happening. So
Okay.
Great going for those who have attempted it in the chat.
All right, so here's another one. So we're gonna use another 2 minutes to work this one. So first, find our difference, find our fifth term, find the term that has 523 matchsticks, and find the expression to calculate the nth term. So what's our difference here? What's our common difference?
We're seeing what we want. We're seeing 13, our difference of 13. It's coming in fast and furious in the chat.
Okay, great going, students. So we know here that our difference is 13. So what would our fifth term be? So what's our fifth term?
We're seeing 68 coming in the chat. Some persons have already generated the nth term. We're going quite well, students. So we're seeing 68 coming up in the chat.
Okay, that's amazing. All right, so we know our fourth term is 55, right? And in order to go from our fourth to our fifth term, we're gonna add the difference. So 55 plus 13, that's 68. So well done, students. So what would our nth term be?
All right, we're seeing responses coming in. 13n plus 3 coming in fast and furious. We see someone made a mistake with 3n, but we know that's a mistake.
Okay, okay, well done, students. So we know that our expression to calculate the number of matchsticks for our nth term would be 13n plus 3. So using that expression, what term has 523 matchsticks?
We're seeing the response that we want.
Okay, okay.
All right.
So in order to get that term that has 523 matchsticks, we'd go ahead and equate 523 to 13n plus 3 and solve for n. Solving for n, we will get 40.
All right. Great going for all of you who got the response.
All right, let's go into something a bit different now. So now we're going to compute the terms of a given sequence, given the rule for the nth term. So let's look at this one. Given the expression 2n plus 3, write the first 4 terms of this sequence. So go ahead for me. Generate the first 4 terms of this sequence.
In the chat, we are seeing 5, 7, 9, 11.
Okay, great. So let's test those answers, right? If we were to generate our first term, right, we know that n would be 1. So substituting n for 1 and simplifying, we'll get our first term to be 1. Our second term, we would substitute n for 2 and simplify. So from that, we know that our second term would be 7. Going again for our third term, we're going to substitute n for 3 and simplify. So simplifying, we get n, we get our third term to be 9. Again, for the fourth term, we're going to substitute n for 4, simplify, and we'll get that term to be 11. So well done, guys. All right, so let's look at this one. Write the nth term of the sequence, right? If a sub n is equal to n plus 4. So this might look a little bit strange to you guys, this a sub n. But that's another way of writing the nth term. So don't be surprised. So write the first 3 terms of this sequence.
All right.
So what are we seeing so far, Mr. Montague?
All right, we're seeing 5, 6, 7.
Okay, great. All right, so in order to get the first term right here, we know we're going to substitute n for 1 and simplify. So we're going to get 5. And our second term, we're going to substitute n for 2 and simplify. So we're going to get 6. Our third term, we're going to substitute n for 3 and simplify. So from this question, let's stay here a little bit. If we're asked for the 20th term of this sequence, right? What would the 20th term of this sequence be?
It's coming in the chat, Mr. Hilton, 24.
Okay, wonderful. So we know that in order to get the 20th term, what we're going to do is we're going to substitute n for 20 and simplify. So that's just 20 plus 4, which is 24. Great going, students. All right, let's see what we have next here. Given that the nth term in a sequence is a sub n is equal to n plus 4. The nth term in the sequence is 25. What is the value of n? So what term in the sequence is 25?
We're seeing the response coming in the chat. We're seeing 21 coming up fast and furious.
You guys are on fire. So how would we work a question like this? So we're given the nth term and we're given the expression for the nth term. By the principle of equality, we can equate those two quantities. So we can equate that 25 to n plus 4, solve for n, and we'll get the answer we're looking for. And in doing that, we'll get 21. Okay, great participation from students. All right, let's move a little bit further, right? So we're here for CSEC, right? So let's look at a CSEC question taken from the May 2016 paper. And it reads, the first 4 figures in a sequence are shown below. Figure 1 is a single block dot, while each of the other consists of block dots arranged in an equilateral manner, as seen here on the screen. So what can we say about these figures? What do we notice about these 4 figures here? So looking at these 4 figures, what do we notice about these figures? What's happening here? So what's the chat saying so far, Mr. Montague?
We're having persons saying it looks like a triangle. The sides are the same amount of dots for each shape or each figure.
Okay.
So they're stating their observation.
Okay. All right, so looking at this figure, you see what I'm seeing? I'm seeing that we're adding consecutive whole numbers. So we started with 1.
Mr. Hilton, we had a response that's saying they recognize that the side is the figure number.
The side is the figure. Okay, great observation. All right, so from these 4 figures, we notice that we're adding consecutive numbers. So we started with 1. We added 2 to that 1 in order to get the second figure. We added 3 to the second figure in order to get the third. We added 4 to the third figure in order to get the fourth. So we're adding consecutive whole numbers right here. All right, let's see what the question asks of us. So figure 5 is shown above. How many dots would be in figure 6? And we're given this table here also to analyze. So how many dots would be in figure 6? And what's happening here in this table? What's happening?
In response to how many dots will be in figure 6, I'm seeing 21 coming up quite rapidly. 21 from Davia, Pamela, Vanessa, Franklin, Cherise, coming up fast and furious.
Okay. All right, we'll look at that shortly. All right, so if we're looking at the table right here, I'm seeing for figure 1, I'm seeing a half times 1 times 1 plus 1. For figure 2, I'm seeing a half times 2 times 2 plus 1. For figure 3, I'm seeing a half times 3 times 3 plus 1. And I'm seeing for figure 11, I'm seeing a half multiplied by 11 multiplied by 11 plus 1. So what's happening here? So if we're looking at the figure number, right? I can say that for the number of dots, D in terms of n, I'm seeing that we have a half multiplied by the figure number, right? Multiplied by the figure number plus 1. Now let's see what else they have for us. So by observation, the number of dots in the figure appear to be half times the figure number times 1 added to the figure number. So therefore, figure 6 is half times 6 times 6 plus 1. So 21 dots is indeed in figure 6. So I hope YouTube is still with us. All right, let's go a little bit further with the question. So what would the expression for the nth term be? So analyzing the information given, what would the nth term be? What would the expression for the nth term be?
All right, going into the chat, I'm seeing a half n times n plus 1.
Okay. So what would the expression for nth term be, students? Looking at the information given. Remember, we noticed that for the number of dots, we have a half multiplied by 1, which is the figure number, multiplied by 1, which is the figure number, plus 1. So how would we use this information, or how can we generate the information for the nth term? All right, looking at this information right here, we have a half multiplied by the figure number, right? And multiplied by the figure number plus 1. So if we're finding the nth term, right, our expression would be a half multiplied by n multiplied by n plus 1. And if we simplify this, students, this expression right here for our nth term, what would that simplified expression be? All right, so simplifying this right here, this expression, a half multiplied by n multiplied by n plus 1, right? We would have a half into n squared plus n. I don't think you guys are able to type it in the chat, so it's displayed on the screen right here. So it's a half into n squared plus n. All right, let's examine another table right here. So we're given this table and asked to complete the missing cells. So what can we say we observe about the area of the triangle and the figure number? What's happening in relation between the figure number and the area of the triangle? What's happening here?
We're seeing coming in the chat, it's n squared, the numbers are squared.
Okay, great observation, great observation. So if we're looking under the column that says area of triangle, I'm seeing 1, 4, 9, 100. And the first thing I notice about these numbers are that they are squared numbers, right? And when I compare that to the figure number, I'm seeing that it is equal to the figure number squared, because for the first figure I have 1 and the area to be 1, which is just 1 squared. For figure 2, I'm having 4, which is just 2 squared. For figure 3, I am having 9, which is just 3 squared. So at the same time, what's happening in relation to the figure number and the number of pins on base? So what's happening between the figure number and number of pins on base? Those two columns. So that's the first column and the third column. What's the relationship there? So what are we seeing in the chat so far, Mr. Montague?
All right, so we're seeing some persons have started generating the Nth term expression, not realizing that it's already there, but good nonetheless. In the chat, we're seeing persons saying add two, add two. All right.
All right, so if we're looking on this first column, we're looking at the third column also. What I see happening is this: I have 2 being multiplied by the figure number, right? And 1 is being added to that. So for each of them, I'm seeing 2 being multiplied to the figure number plus 1. All right, so with that bit of information, so we're at figure 4. So the area of triangle 4, what would the area of triangle 4 be?
The responses had flooded the chat. Mr. Hilton, 16 was coming up fast and furious.
Okay, great. So we know that for our area of triangle, it's just the figure squared, the figure number squared. So we have 4, so that's 4 squared, which is 16. So what's the number of pins on the base? What would the number of pins be for figure 4?
All right, it's in the chat. 2 times 4 plus 1, which is 9. It's coming up fast and furious. 9, 9, 2 times 4 plus 1. It's coming up. We're seeing what we want.
Okay, great. So in order to get the number of pins on the base, it's just 2 times 4 plus 1, which is just 8 plus 1, 9. So we're in the 5th row right now. So looking at the 5th row, I'm seeing in the third column, 2 times 8 plus 1 equals 17. So what's the figure number and what's the area of that triangle? So what would the figure number be?
In the chat, we're seeing figure number 8. Figure number 8, area of triangle 64. 8, 64, 8 and 64.
Okay, great. So again, we know that for the number of pins on base, it's just 2 times the figure number plus 1. And so that's just 2 times 8. So from this, we can say that 8 is our figure. So considering that 8 is our figure, what would the area of that triangle be? And yes, it is 64 because we know that the area of our triangle is just the figure number squared. So it's just 8 times 8, 64. So for our 6th row, we're given the area of the triangle. So we're given the area of the triangle to be 100. What's the figure number here?
All right, we're seeing figure 10 coming up. Figure 10. Persons then writing the number of pins on base as well.
Okay, so from this, so we know that in order to get the area of the triangle given the figure number, which square it. So if we're moving from area of triangle to figure number, we'll do the opposite of that. So we'll take the square root of 100. So the square root of 100 is 10. So I'm using 10 for a figure number. The number of pins on base would be 2 times 10 plus 1, which is just 21. And for figure 100, what would the area of that triangle be?
10,000 is coming up, 10,000 for the area of triangle.
Okay, great. And what would the number of pins on base be?
Number of pins on base, 201, 201, 201.
Okay, great. So we know that for the area for a triangle, it's just the figure number squared. So it's 100 squared, which is 10,000. And for the number of pins on base, that would be 2 times 100 plus 1. So that's 200 plus 1, which is just 201. All right, great. So what would be our expression to calculate the area of the triangle in the nth position?
We're seeing it coming up in the chat, n squared, n squared.
Okay, okay, great, great. So it is indeed n squared. So if we're asked to find the area of the triangle in the nth position, it would just be n squared. All right, let's look at another CSEC question. So the nth term, t sub n of a sequence is given by t sub n equal 3n squared minus 2. Show that the first term of the sequence is 1. What is the third term of the sequence? And given that t sub n is equal to 145, what is the value of n? So type that in the chat for us. So first show that our first term in the sequence is 1, and write the third term of the sequence and find n when the nth term is 145.
All right, so Cherise is out of the blocks, typing out her answer, and they're working in the chat for the first, for number Roman numeral 1. Peter is doing the same thing, Peter Ann.
All right, so let's see how it works. So we're given our expression for n term, which is 3n squared minus 1, and we are asked to show that the first term is 1. So what we're going to do is we're going to substitute n for 1 and simplify. So substituting n for 1, that's just 3 times 1 squared minus 2, which is just 3 minus 2, which is 1. So indeed, our first term of this sequence is 1. All right, so then we're asked to find the third term of the sequence. So finding the third term of the sequence, again, using the rule, we're going to substitute n for 3 and simplify. So that's just 3 times 3 squared minus 2. So that's 3 times 9, 27 minus 2, 25. All right, great. So let's look at Roman numeral 3. So given that t sub n is equal to 145, what is the value of n? So what term is equal to 145?
Cherise again out of the block, saying 7.
Okay. All right, just giving the others a few more seconds to come up with their answer.
All right, the chat is being flooded with 7.
Okay, okay, well done. So let's see the working out for this. So we're given the expression for the nth term, and we're given the nth term. So by the principle of equality, we can equate those two. So we're going to equate 145 to 3n squared minus 2 and solve for n. In solving for n, we get n to be equal to 7. All right, well done, students. Well done.
All right. I'll take it from here. Mr. Hilton.
Okay, go ahead, Mr. Montague.
All right, good afternoon again, students. And we're looking at this. It's another CSEC problem. Now, it states a sequence of figures is made up of stars using dots and sticks of different lengths. The first 3 figures in the sequence are shown to the right. So what I want for you to do right now, students, since it is made up of dots and sticks, I want for you to identify the figure number. So you'll say FIG1, and then the first number that you write will be for the number of dots, and the second number you write will be for the number of sticks. So remember, figure number, then dots, then sticks. So what I want the number of dots and sticks in figures 1, 2, and 3. So when you're putting your answers in the chat, I want all 3 answers. So FIG1, then you put how many dots, comma, then how many sticks. You put your space bar. FIG2, then you put how many dots, then how many sticks. Then FIG3, how many dots, how many sticks. What does your chat look like? We're going to give you approximately 2 minutes to do just that. Remember, we want to know how many dots and how many sticks are in figures 1, 2, and 3. Take your time and count.
All right, so I'm seeing responses in the chat so far.
Are we seeing what we want? Figures
All right,
1.
So I'm seeing figure 1, 13 dots, 12 sticks.
All right. 13 dots, 12 sticks. How many for figure 2?
All right, so I'm seeing persons also saying figure 1, 12, 12.
All right.
And majority of persons saying figure 1, 12, 12.
All right. I hope persons are seeing that there's a dot in the center. Pay close attention. You're my detectives.
So I'm seeing from Sterling here, figure 1, 12, figure 2, 24, figure 3, 36.
Are we referring to the number of dots or the number of sticks? Be quite specific, my little detective. So be very careful as we're using our observation skills now.
Sarah is saying figure 2, 24 sticks, 25 dots. Franklin is saying figure 4 is 48 dots.
Interesting, Franklin. All right. So since we have already counted our number of dots and our sticks, all right, this is how the question looks. All right. So a lot of persons, they didn't count the dot in the center. So it's important for us to recognize and use our investigative skills. All right, so it says, study the pattern of numbers in each row of the table. Each row relates to a figure in the sequence of figures. No, some rows have not been included. And you as the detective, you're asked to complete rows 1, 2, and 3. So you have been doing that. Now, students, it's very important. You recognize that myself and Mr. Hilton, we have been looking at common difference for quite some time, allowing you to generate the Nth term. So in most CSEC questions, they won't be asking you about common difference. So it's up to you to recognize just how important it is. So can we complete row 1? What's the response coming in and looking like, Mr. Hilton?
All right, so I'm seeing you add 12 sticks for each figure. And that was said by Cherise.
All right, great going. So using that logical deduction, the 5th pattern would have how many number of sticks?
So I'm seeing Brooke saying 5, so he's looking at Roman numeral 1, 60 sticks and 61 dots.
All right, so we're seeing the responses that we're wanting. Is it coming in fast and furious?
Yes, it's being flooded, it's being flooded.
All right, great going, detectives, great going. All right, so we're seeing. All right, so now at this point, we want to complete row 2.
So I'm seeing 13 and 157.
All right, great going, great going, great going. All right, so all we would have to do would then just to divide by 12 in order to get our 13, and then just add 1 to our 156 to get our 157. Great going.
And I'm seeing Damani working out figure 6 for us. He's saying that he has 72 sticks and 73 dots.
All right, great going. But remember, it's a time-sensitive exam. So we don't want to answer any question that is not required of us. All right. So I want for you to pay close attention and go right ahead onto row 3.
And I'm seeing similar answers over here on YouTube also.
All right, great going, my YouTube viewers. Remember, at this point where you're seeing n, they want you to generate that nth term expression. Remember, that's where the common difference comes in, and you should recognize and know what to do from there. Come on, my detectives, you know what to do, you know what to do, you know what to do. Are we seeing what we want in the chat, Mr. Hilton?
So I'm seeing Cherise saying n plus 12 for the number of sticks and n plus 12 plus 1.
Are we sure that's what we want? N plus 12. If we have 1 plus 12, 2 plus 12, 3 plus 12, would that work? Come on. When we get the common difference, what did we say?
And I'm seeing D equaling 12n and S equaling 12n plus 1.
All right, great going. We recognize our coefficient and what we're going to be doing, what other operation we need.
I'm seeing 12n plus 1 for dots, 12n plus 1 for dots, and 12n for sticks.
All right, great going, students. Great going. You see just how important identifying our common difference is. Great going. All right, so this is the working for those who were not following. Since we recognize that we're going up by 12, all we needed to do was just to multiply figure 5 by 12 to get our 60 dots. And then we would then add 1. So it would be getting 61 dots. And since we're multiplying 12 each time in order to get our figure number, we would then just divide by 12. And that's how we would end up with 13 there. All right. So great going, students. Now I want for you to look at this extension to this question. Pay close attention, students. Look at it, read it. When you're given a question, even if it seems wordy, read it twice. The sum of the number of dots in two consecutive figures are recorded. This information for the first three pairs of consecutive figures are shown in the table below. So we have figure 1 and 2. We have 13 plus 25, which is 38. Figures 2 and 3. 25 plus 37, which gives us 62. Figures 3 and 4, which would give us 37 plus 29, which results in 86. The question states, determine the total number of dots in figures 7 and 8, and then figures n and n plus 1. All right, you may start now, my detectives. What are we seeing?
All right, so I'm seeing so far 182.
All right.
182. So I'm seeing that from Talma and Vanessa Wilson. Cherise is also saying 152. That's 182.
All right, let us examine it together, because I'm sure there are some students are saying, really, where are they getting all of these figures from? All right, I'm here for you. All right, so we recognize that there's a rule that is going on. All right, so if we want figure 7, we would then say 12 times 7 plus 1. And if we want figure 8, it would be 12 times 8 plus 1. When we add those together, we get what we want. All right, so I'm here for you. Don't worry, I'm not going to let you go.
Faith Williams worked it out beautiful for us in the chat.
All right, great going. All right, so are we ready for question 2? I'm still here. I'm holding your hand. I'm not letting you go. We're getting through this. You're doing so well. Great going, students. All right. Are we seeing anything coming up in the chat for question 2?
Not yet, Mr. Montague. Let's give them a few more seconds. All right, so I'm seeing 12n plus 1, and that's from White.
All right, let's work on it together. I'm holding your hands. Remember, I'm not letting you go. We're doing it together. All right, so we recognize this is what we have. It's going to be 12 times n plus 1 plus 12 times n plus 1 plus 1. Bear that in mind. So if we are to simplify that, we would have 12n plus 1 and 12n plus 12 plus 1. So I'm giving you a minute to simplify that, to look at it and simplify. So we're determining the total number of dots in figure n and figure n plus 1. I'm thinking that
what I'm seeing so far, I'm seeing from Vanessa 2 open bracket 12n plus 1, and I'm seeing 24n plus 14 from Faith. Same thing from Sterling, Talma, White, Watson, Simpson.
All right, great going, my detectives. Great going, great going, great going. 24n plus 14 is our correct response. Great going. All right, now, so what we have here is another CSEC question. And so it says a sequence of figures are made from joining polygons of unit length. The first 3 figures in the sequence are shown below. And I want for you to draw figure 4 of the sequence. Come on. put on your observations cap. 1 minute. In fact, you don't even need 1 minute. 32 seconds. All right. Are we seeing what we want in the chat, Mr. Hilton?
All right, so I'm seeing so far 4 fences.
All right. I'm hoping that when you draw it, my detectives, it looks like this. So great going. For those who attempted the question, great going. All right, now we have another pattern that I want for you to look at, students. All right, it says study the patterns of numbers in each row of the table. Each row relates to a figure in the sequence of figures. Some rows have not been included in the table. So I want for you to complete row 1, 2, and 3. All right, so look closely. Put on your observation cap, your spectacles, your binoculars, whatever my young detective needs. Notice if there's a pattern that you're seeing coming out, and we're going to discuss it in a little while. So go ahead, complete rows 1, 2, and 3. All right, so while we're working, I'm going to bring the others with us because I'm holding your hands. I'm not letting you go. All right, so I'm right there with you. So on figure 1, we're seeing the number on the outer lines. We're seeing 1 plus 2 plus 2. So I'm wondering, where's that 1 coming from? Let's go to figure 2. So I'm seeing figure 2. It is numbers on the outer line. It is 2 plus 2 plus 4.
So what I'm seeing in the chat so far, I am seeing 6 plus 2 plus 8, 6 plus 2 plus 12, 6 plus 2 plus 8, 6 plus 2 plus 10, 6
All
plus
right.
2 plus 12, and that's the most I'm seeing right now.
All right, great going.
20. I'm getting 20.
All right, my detectives. All right, you're seeing a pattern coming out. So the first value or the first number would be the figure number. Then we have 2. And that third number, where did it come from? How did we get that 2? Can we see a relationship coming on here? I'm hoping most of my students are seeing that we're actually multiplying that figure number by 2. So firstly, we have the figure number, then we add 2, then we multiply the figure number by 2. Third figure, we have the figure number, then we add 2 when we multiply the figure number by 2. So for the 6th figure, all right, what should we have? Are we seeing what we should have?
So I'm seeing 65.
All right, my little detectives, come on. We have, for this, let's just finish up row 1, which we know is going to be 6 plus 2 plus 12, which would give us 20. All right, and for 65, I think persons are now ready.
And in response to your previous questions, persons answered and said multiplied by 2 times 2.
All right, great going, my detectives, great going. Any response to complete row 2?
So what I'm seeing from Wilson, that's Vanessa, she says 21, and I'm seeing 21 plus 2 plus 42, and I'm seeing 65. So the figure number would be 21.
All right.
And
Okay.
Wilson also said n plus 2 plus 2n and 3n plus 2. So she gave the expression for the nth terms.
All right. Great observation. I'm hoping the others are catching on. Great observation. Great.
Morris is saying figure number 21 and also white.
Very good. Very good. So when we simplify, I recognize a number of persons that jumped the gun and had given us our end term expression. Great going. Great going. Great going.
And I'm seeing similar answers on YouTube also.
All right. Congrats. All right. Let's look at another question. All right. So now Bianca, she makes hexagon using sticks of equal length. She then creates pattern by joining the hexagons together. So we can see pattern 1, 2, and 3 are shown below. Look closely at them, my detectives. Look closely at them. The table below shows the number of hexagon each pattern created and the number of sticks used to make each pattern. All right, students. So I want for you now, in the table, we're seeing X, Y, and Z. What would we place in each of those? You have 2.5 minutes.
So I'm seeing from Watson, figure 4 has 4 hexagon.
All right.
I'm seeing X equal 21, Y equal 26. I'm seeing 21, 26, 31.
Okay, okay. Come on, students, you're my detective. I want for you to pay close attention to every detail.
I'm also seeing Z equal 101, Z equal 31, Z equal 32, Z equal 101. I'm seeing S equaling 36 in the chat.
All right, my detectives, I want for you to pay close attention because sometimes when we're given a table and we're seeing consecutive numbers coming down the line, we tend to ignore what our brain is telling us to do. So we're seeing 1, 2, 3, 4, 5. So our brain is telling us that we're not seeing 6, but we want to believe that 6 is there. Pay close attention to what we're seeing. All right, so just by looking at this table, my little detectives, I recognize, and I'm sure you can see that there exists a common difference. All right, so the common difference of 5, so we would be looking at our n term having 5n. That's the first thing. But would that generate 6, 11, 16? Think about it. Do we need to do another operation to allow us to get 6? What should we do? Think about that. So if we have 5n, what else should we do?
So I'm seeing Brooke saying Z equal 101 and also Sarah. Sarah is saying +1.
Very good, my detectives. So if you're going to have 5n plus 1, that means for the 4th term, it would be 5 times 4 plus 1. For the 5th term, it would be 5 times 5 plus 1. And for the 20th term, it would be 5 times 20 plus 1.
So I'm seeing Brooke, Watson, Simpson agreeing with you with 5n plus 1. Simpson
right.
saying 5 times 20 plus 1.
All right. Great going, my detectives. Great going. Great going. For those who don't see it as yet, we're going to be looking at it. But there's an addition to the question, and I want for you to recognize that. So we have already done, calculated or determined the value for x, y, and z. It then says write down the expression for s in terms of n, where s represent the number of sticks used to make a pattern of n. Who can first put that in the chat? Let's see. Remember, write down the expression for s in terms of n. Do we have anyone out of the blocks yet, Mr. Hilton?
No, not yet. I'm seeing 5n plus 1, s equal 5n plus 1.
Great going for that person who put it in. So you have written down that expression for s in terms of n. All right. Now it says Bianca used a total of 76 sticks to make a pattern of h hexagon. Determine the value of h. Are we ready? I know my detectives are ready. Are they flooding the chat with the answer just yet?
All right, so what I'm seeing so far is s equal 1 and n equal 5. So from Wilson, I'm seeing 5h plus 1 equal 76, 5h equal 75, and h equal 15.
All right.
So Talma is also saying 15.
All right. All right, since we recognize that we have a common difference of 5, and we'll be generating the nth term to be 5n plus 1. So we would then be getting that our x would be 16 plus 5, or y would be 21 plus 5, and our z would be 5 times 20 plus 1. So we'd be ending up with 101. So those would be the answers for 1, 2, and 3. All right, so we're then given 76. So as Mr. Hilton had shown us earlier, we will just use the principle of equalities. So 5n plus 1 is equal to 76. Simplifying further, 5n is 15. Sorry, 5n is 75 and n is 15. So the number of pattern where h is equal to 15. So for those who had said 15, great going. Let's look at another CSEC question here. My detectives, let's look at it. A minute to read, and then we start discussing. All right, the diagram below shows the first 3 diagrams in a sequence. Each diagram is made up of equal length, which are joined at the end by bars of plasticine. Diagram 1 is made up of 12 wires and 8 balls. Each new diagram in the sequence is formed by fitting the frame shown below to the right of the previous diagram. So in the chat, I want for you to tell me how many wires are in diagram 2 and how many balls are in diagram 2. Diagram 2 is what I'm referring to. Look closely at it, count all of them. How many wires, how many balls?
All right, so what I'm seeing so far, so Watson is saying 24, 12. Talma is saying 20 and 12. Wilson, diagram 2, 20 wires, 12 balls. Asha is saying 20 wires and 12 balls. Akeem is saying 12 wires, 12 balls.
All right. Great going. All right, so in that same vein, what I want for you also to do, students, I want for you to draw diagram or sketch it. Sketch diagram 4. What would diagram 4 look like? So I want for you to sketch it and then you'll compare it with what I'm going to bring up on screen next. All right. Diagram 4, sketching. All right. So make sure that you have your diagram 4. We're going to bring that up in a short while. So since we have recognized that figure 1 has 12 wires, 8 ball, figure 2, 20 wires, 12 ball, figure 3, 28 wires, 16 ball. How many wires would we now have in figure 4 and how many ball?
So white is saying 36 wires, 24 balls. Also Sarah, Akeem.
All right.
Wilson is saying 36 wires, 24 balls.
All right, so what about diagram 20? How many wires, how many ball?
All right, so Akeem is saying 164 wire and 84 balls for diagram 20.
All right, so our sketch of diagram 4 would look something like this. I'm hoping that's what you have so far. So our sketch of diagram 4 would look like this. All right, so if we were now to complete our table, we would be looking at and let's just talk through this. Now, in the number of wires, are we recognizing that there's a common difference happening there? Just going down the column, number of wires, are we recognizing our common difference? What does the chat look like, Mr. Hilton?
All right, so what I'm seeing so far, Vanessa, White, Beric, Pamela, Brown saying 8. Cherise also saying 8.
All right, so very good. So we're recognizing our common difference again here, which is 8, which will give us our coefficient of n. So if we substitute 1 for the first term, which would be 8 times 1, we would get 8. But what we actually want is 12. What other operation can we implement in order to get 12? Are you seeing that coming out, my little detectives?
So I'm seeing Vanessa saying add 4.
All right. So that is our rule is coming out, which is 8n plus 4. Can we generate a rule for the number of balls? Note the common difference, come on.
So I'm seeing Vanessa and Akeem saying 4n plus 4.
4n plus 4. Great going, great going. You have done very well. very well today, students. And so I am quite pleased with you so far. And at this point, we're going to give you a little post test. All right. So Mr. Hilton will put it in the chat. Those who have a QR scanner, you can scan this and you will be taken directly to where you can start doing a post test. Good luck. I think you only need 5 minutes. I don't want you to leave just yet, students. You have an evaluation that you're going to do after, so don't leave just yet, please. So I'd like to get a feedback on the workshop. How do you feel about it? So don't leave just yet. So after you have done the post test, please come back so we can do the evaluation. All right. For those who want to try the question, the last one is from June 2013. All right, welcome back to those who have completed the post test as well as the evaluation. I want to thank all of you for tuning in over the last 6 weeks. It's been our pleasure to serve you and to work with you. And remember, you can always go back online on YouTube and view every one of these presentations. And we do wish you prosperous in your exam. We expect that you're going to do well. We expect that you're going to continue practicing. All right. Mr. Hilton.
Okay, so I love the level of participation from our students, and I hope that they all do well on their exam. I know they'll do well on their exam. Just practice, practice, practice.
All right. I know everyone appreciated the presentation. So all of you who are saying thumbs up and thank you. It was our pleasure. It was our pleasure serving you, working with you, and holding your hand as we went through this. All right. And remember, math is easy. All right. You just need to appreciate it and